All right, so we are on the chapter 3 worksheet review, and we are going to begin with the practice problems. And again, as normal, we'll assume the point of view of an economist. So let's get this started. So we have question number 1, where we have Angela is a first-year college student fresh from the Whitney bubble. She takes a full load of classes and has only 5 hours per week for her hobby. Angela is an artistic soul and can make 2 clay pots per hour or 4 coffee mugs per hour. So let's take a look at it here. So again, in 1 hour, she can produce 2 pots and 4 mugs. So you're asked in part A is to draw Angela's production possibility frontiers for pots and mugs. And really you should have what I will be putting here. Again, with mugs as the y-axis and pots as the x-axis, we would then multiply by 5, so we'd have 10 pots and 20 mugs. And then we can place that here. So in this case, we put the 20 mugs here where the red part is up on the top, and we can have our 10 pots here, and then we simply create our production possibility frontiers as follows. That's a straight line that I could get for you guys. So your chart should have looked like this, and if it didn't, there's a small problem. We move on to B. What is Angela's opportunity cost of 1 pot or 10 pots? So we have the information that we had before, and this is where I'm going to start giving you some of the formulas, so to speak, to be able to calculate this easy and without much stress or effort. So we have, and we use a chart. So we plug in the information that we already have. So we already know that in a 5-hour period that Angela can create a maximum of 20 mugs, but of course she can't do any pots at all. From looking at the production possibility frontiers, we can then move on. If we look at the midpoint, which you can see here, she can produce 10 mugs or 5 pots. And we can also take the information that we have before. She can produce a maximum of 10 pots, but no mugs. So that's the filling up of our chart. So the next thing that we need to do is to find out what the opportunity cost is. And again, there's a simple formula for it, and you may want to jot it down as I'm going through this material, which is how do we calculate the opportunity cost. So the first step is to calculate the difference. What does that mean? We look at the different columns that we have and see what is the difference between, let's say, point A to point B to point C. So in our case then, if we look at point A to point B in mugs, we can see the difference between them is 10. When we look at point B and C, we can also see that the difference is 10. We can do that same thing with the pots. 0 to 5, the difference is 5. 5 to 10, the difference is 5. So that's our first step. Now, of course, sometimes the differences will be won't quite be as easy because of the use of resources and so on and so forth. But we're not going to get into that right now. Our second step is to do what I call write the sentence. And here is an example of the sentence. The opportunity cost of how many pots is how many mugs. That's our sentence. The next step is then to plug in the numbers. So again, we use the numbers that are right in front of us, and we can do it this way. The opportunity of 5 pots, we can see pots there, will be, and you already know, is 10 mugs. So we have that there. But still, we do need the opportunity cost for 1 pot and for 10 pots. So what's the next step? Well, we do want to come up with the opportunity cost of 1 pot. Well, the only way to do that is simply to divide, or divide it against itself. So the only way to get to turn 5 pots into 1 pot is to simply divide by 5. 5 divided by 5 will be 1, but we need to do it with the mugs as well, and so we simply divide it by 5. Again, we do our calculations, we crunch the numbers, and then our opportunity cost of 1 pot simply becomes 2 mugs. Now, it's very simple. You can do it in your head with numbers like this, but when the numbers get more complicated, you do really need to have a simple formula to do. So we've answered the first part, but what is the opportunity cost of 10 pots? Well, all that we have to do is simply multiply these numbers by 10. So the opportunity cost of 10 pots, 1 times 10 is 10. The opportunity cost of the mugs, well, 2 times 10 is 20, and we have it. The third question is, what is Angela's opportunity cost of 1 mug and 10 mugs? That is to say, we turn them around. Again, we have the same information that we had before, and we simply plug everything in. We write the sentence, and now in our sentences, the opportunity cost of 10 mugs is 5 pots. We've had this before. It's right in front of us here. We simply find a way to look at 1 mug. So we divide it by itself. 10 over 10 will be 1. And of course, we have to do the same thing with the pots, 5 over 10. So we get this number here. The opportunity cost of 1 mug is a half a pot, or 0.5. So when we plug in the numbers, multiply it by 10, the opportunity cost of 10 mugs is 5 pots. Hopefully you've all gotten that answer. So let's move on to continue on here. Why in D is, why is her production possibilities frontier in a straight line instead of a bowed out line by those presented in chapter 2? And the answer is very simple. Because, well, I misspelled her. Because her resources can be moved from the production of one good to another at a constant rate. In this case, there's only one person doing the labor. There's still the same number of clay for the pots as there are for mugs. So there really isn't any change. There's no different use in technology for both and so forth. So all of it is constant. Now, if she was in a factory with experts in pots and experts in mugs, then it would be bowed out a little bit. I'm exaggerating it here because of the different rates of production based upon skill. Or if one person had to do pots by hand, as opposed to someone making pots, let's say, through a mold, that would be technology. There would be a difference, and that would be shown through the bowed out section. But for right now, we just assume production is going to be at a constant rate. Here now we move to question number 2, where suppose a worker in Germany can produce 15 computers, or he can produce 5 tons of grain per month. And suppose a worker in Poland can produce 4 computers, or 4 tons of grain per month. And for simplicity's sake, assume that each country only has 1 worker. That's why we don't have to deal with any bowed out production possibility frontiers. So taking this assumption in mind, we must begin by filling out the table. And again, this is the same information that you had in the last slide. So let's plug that stuff in. So we've been given this information. Germany can produce 15 computers, or they can produce 15 tons of grain per month. And the worker can produce 4 computers or 4 tons of grain. So that's part 1, filled up the table. Easy peasy. Let's move on. For B, which is graph the production possibility frontier for each of the countries below. And you should have created graphs just as I did. In this case, I'm putting computers as the y-axis and the grain as the x-axis. So You should have had something similar to this with the Germany with computers at 15, moving down to 5. I think that's pretty obvious. And on the same scale, Poland 4 and 4. We can see automatically that Germany has a much stronger and more efficient economy than Poland does. So let us move to C. What is the opportunity cost of a computer in Germany, and what is the opportunity cost of a ton of grain in Germany? So again, we do what we did last time, calculate the difference. Now, we really don't have to do any calculations here because we've just been given 2 bits of information, so that's all that we need to do. It's already been given to us. We can now write the sentence. The opportunity cost of how many computers is how many tons of grain. We'll start with Germany. The opportunity cost of 15 computers is 5 tons of grain. And then, again, we need to divide so we can have 1 computer to how many tons of grain. We divide it by itself. Now we know that the opportunity cost of 1 computer is 1/3 of a ton of grain, or 0.33 to infinity. We can do the same thing now for Poland, and Poland is very simple because the opportunity cost of 4 tons of, excuse me, I need to do the other side for Germany. I'm anticipating myself. I need to find the opportunity cost for grain first and then computers. So again, we simply divide the tons of grain, so we will know how much 1 will be, 5 by 5 on both of these, and we can see easily the cost of 1 ton of grain is 3 computers. Notice it's they're the inverse of one another, so that does help as well. There is a connection between the two. We can do now the same thing with Poland, and that's what I anticipated just a little bit. And Poland is crazy easy because the numbers are identical. The opportunity cost for 4 computers is 4 tons of grain. 4 over 4, we carry it to the grains, and it's going to be 1 ton. 1 to 1. And we do it the other way around. I know it's not necessary, but let's just show the step. 4 to 4 does it exactly. And that's how it is. So we know the opportunity cost of Germany. We know the opportunity cost of Poland for both of these items simply by using this simple formula and plugging in the numbers. So our next question is, which country has the absolute advantage in producing computers and grain? And in this case, it's just a question of comparing numbers from one country to another. The bigger the number, well, that means they have the absolute advantage. Now, the next question is, of course, just to remind you, what is absolute advantage? And of course, the ability of an individual or group to carry out a particular economic activity more efficiently than another individual or group. So in this case, we look at the Germans and their computer work and compared to Poland. The Germans can make 15 to Poland's 4. Germany has the absolute advantage. When we look at grain, we can see 5 to 4. Well, 5 is a bigger number than 4. Germany has the absolute advantage. The winner on both terms is Germany. Deutschland über alles. The F question, which country has the comparative advantage in producing computers or grain? And again, this begs the question, was ist comparative advantage? And it's defined the ability of an individual or a group to carry out a particular economic activity, such as making a specific product, more efficiently than any other activity. And this is where we go back to material that we've had earlier. Here's our chart. So we now need to calculate comparative advantage for computers and comparative advantage for grain. We can use the information that we have, which was the opportunity cost, which we did earlier on in the example. So to save time and trouble, we simply do it this way. We can calculate the comparative advantages for computers. 5 over 15.33. Again, uh, we had this number just recently, and we could do the same thing for a ton of grain. 15 over 5 is equal to 3. For Poland, simple. 4 over 4 to 1, 4 over 4 to 1. So now we have to see who can produce more efficiently. We're looking for the smaller number now to figure out comparative advantage. In the case of computers, we can see for the Germans, it's cheaper for them to produce computers as compared to Poland. Poland will do 1. The Germans can produce basically 3 at the same time. And when we look at grain, it's much more expensive for the Germans to produce grain, but comparatively cheaper for the Polish to do it. So we have 33.33 for the Germans for computers, 1 for grain. Poland has the comparative advantage for grain. So for this, each country should tend towards specialization in the production of which good and why. And you probably already figured out that Germans should focus on computers and Poland should focus on grain. For H, this is a little more complicated, but it's still very easy, which is the range of prices for computers and grain for which both countries could benefit. And again, for exactly how much each country should be trading with one another is very open, as long as you stick to a few rules. So let's take a look at the numbers that we had just from earlier. And your basic answer is grain must cost less than 3 computers to Germany. That is to say, it's a good deal for Germany if the grain was at 2.8 or 2.5 or 1.5 or whatever it is. And the other way around, computers must cost less than 1 ton of grain to Poland. Anything within that range will work. Thus, they should trade. Suppose Germany and Poland settle on a price of 2 computers for 1 ton of grain, or ½ a ton of grain for a computer. Suppose each country specializes in production and they trade 4 computers for 2 tons of grain. Plot the final consumption points on the graphs provided. So here we have our situation. Germany and Poland settle on a price of 2 computers for 1 ton of grain. So they take their stuff with them, which is the same as saying it's ½ a ton of grain for a computer. Which brings us then to each country specializes in production. Germany specializes in computer, while Poland specializes in grain, and they trade 4 computers for 2 tons of grain. And so comparatively, we can now plot the final consumption points based on all this material as follows. So we have our information here. We can bring out our production possibility frontier. Now I changed the size of the graphs just to make it easier to see. So we have our original material here, Germany and its computer and grain building 15 and 5, and Poland with 4 and 4. They are now trading with one another, and based upon the information that we have, Germany gets, again, Germany does its trading, and so we can see that the production possibility frontier is moving. And so based on, again, 2 tons of grain for 4 computers and so forth, Germany's production possibility moves outward. Germany now is comparatively richer than it was before through trade. Poland does the same thing. It gives up. It gains computers for giving up 2 tons of grain. And as you can see here, Poland's production possibility frontier moves to that center point there. Poland becomes comparatively richer through trade. Trade helps everybody as long as there's comparative advantage. For J, suppose the productivity of a worker in Poland doubles so that a worker can produce 8 computers or 8 tons of grain per month. which country has the absolute advantage in producing computers? And again, we simply plug in now the new numbers. So Poland now is at 8 and 8 for computers and grain instead of 4 and 4. So we calculated before. We can see the absolute advantage here. Now Poland has absolute advantage in grain. So K, after doubling the productivity in Poland, which country has a comparative advantage in producing computers and grain? Has the comparative advantage changed? Well, plug in the numbers. We've seen these numbers before. Germany remains the same. Poland, however, remains the same. 8 over 8 is the same as 4 over 4 is still going to be 1. Poland obviously has the same advantage in grain, comparative advantage, than the Germans on computers. So they should still continue to trade as they did before. And the last question was, how would your analysis change if you assumed, more realistically, that each country had 1 million workers, and it should make absolutely no difference because it would not change absolute advantage or comparative advantage. It would change the scale in which the previous two graphs by a factor of 10 million. Shoot, we can increase both sides by a billion, a trillion, a quadrillion, and it would still remain the same. We move on to the third question. Suppose that a worker in the United States can produce 4 cars. Here we go. Here's our guy. He can produce 4 cars or 20 computers per month, while a worker in Russia can produce, come on, stop producing. There we go. That our worker in Russia can produce 1 car or 15 computers per month. Again, for simplicity, assume that each country has only 1 worker. So let's fill in the table provided. Now, in this case, we're doing cars, computers, and we're looking for comparative advantage as well. Well, we've been given the data. We've been given 4 cars and 20 computers for the United States, 1 car and 5 computers for Russia. So let's do our calculations. Which country has the absolute advantage in production of cars and computers? And we can obviously see in both cases the United States has the absolute advantage for the production of both. So let's figure out the comparative advantage in the production of cars and computers. In this case then, 20 by 4 is 5. 5 by is 5. 4 by 20 is 0.2. Again, it was just simply looking at a simple formula for comparative advantage. And we do the same thing with Russia. 5 over 1 is 5, and 1 over 5 is 0.2, based on the data that we've been given. Now, here is an interesting situation. Okay, are there any gains to be made from trade, and why? And this is one of the rare situations where, well, it doesn't work because neither has a comparative advantage in either good. If you take a look at their comparative advantages between cars, they're both identical, 5 and 5. For computers, it's identical, 0.2 to 0.2. There is no advantage in trade. And this is one of these rare incidences where this does happen, but they have to be basically coming up identical in comparative advantage. So does your answer in D above help you pinpoint a source for gains from trade? And the answer is yes. And the answer is why? There needs to be differences in opportunity cost in producing goods across countries for there to be gains from trade. Without it, there is no need for trade. What might make 2 countries have different opportunity costs of production? And I asked you to use your imagination. So why would they have different opportunity costs? And among them could be the workers have different levels of education. Let's say education in certain skills in Russia are better than in the United States, and the other way around. It could be the land could be of different quality. The United States, for example, has less land than Russia does, but our land is more productive for reasons of nature and so on and so forth. Capital could be of different quality. For example, the machines in the United States could be equipped with robots to help make things more efficient, as opposed to Russia, where they may be using less efficient techniques because they don't have the technology yet. It might be, or really, I'm just repeating myself, the available technology might be different. It could be as simple as coming up with different ways of doing things, just different work routines. And in other words, the availability of resources or technology might be different across country. And that would bring everyone into account on the differences and why it's necessary to trade. A nation like North Korea would gain so much from trade with the rest of the world because it has, the other countries may have absolute advantages, but North Korea, for example, has more rare earths than any other country, and if they could just take that comparative advantage, they could do extremely well by trading. Alas, they do not.